Alright guys, you may wonder why there's already work here. The answer to that question is that I solved these first two questions yesterday, and as I was trying to make this video, of course my laptop decided to restart right in the middle of me making the video, and as a result I lost the whole video. So I can scrap these and start fresh, and that's exactly what I'm going to have to do, but it's okay. It's okay. Not like I need any more practice doing mesh, but I guess that's just the way it goes. So, it seems like people had some trouble with these problems, so what I'm going to do is I'm just going to go through and solve them. I want to put them in Spice first so that we can see those voltages that we're expecting. I already have them made, so it's going to be, actually it's in my homework 8 folder. I've got 2A, and I've got, let me get the other one, 2B. Oh, you know what? Let me open it through here, just so that I have them both open and ready to go. Oh, that's homework 1. I want homework 8. 2B. Alright, so now I've got 2A and I've got 2B. Let me just throw the .op statements in both of these. That one's got it already. So I'll run this one. You'll see that I get 2.133, 3.133, and 0.133. Those are my voltages, so that's what I'm going to be looking for. So you know what, let me just go and write those voltages down on this first page. This is VA1 is equal to 3.133, VA2 it's 2.133, and then VA3 is 0.133 volts, right? Box that just so that we know that that's what we're looking for. And we come over here, so I've got those written down now. So let's go ahead and go through the mesh. Let me get these other pages out from underneath here so that they're not distracting. Alright, so basically I'm just going to go ahead and solve this, and I'll talk through it. I don't want to take it too slow, but also don't want to take it too fast, so I'll just talk myself through it. So I would define my currents first and foremost. Again, we've talked about this several times. It really doesn't matter how you define your currents, because it's going to work out in the end. So I call that I1, I2, and I3. This is going to be mesh, so this is going to be 2A mesh, basically. I'll label the page 2A mesh, and I'll scan these notes and upload them along with the video. But basically I'm going to have to leave myself a little bit of extra room over here to do some calcs at the end, and I want to keep it neat. So first and foremost, I need to, well, I don't need to do this, but I like to do this. I like to write my plus minuses, right? If current I1 is flowing this way, I know that this voltage has to be higher than that voltage, so I write my plus minus like this. This is just, it helps me know that I'm dropping voltage across these resistors, and then this one would be this way. Okay? So what you're going to do is you're going to notice first that I1 is equal to 1.2 milliamps, right? You don't need to write a loop equation for a loop that has a current source in the branch. This branch is the current I1, right? If you were over here, the only current that flows through this 1K is I2. So the only current that flows through this branch is I1, which is the 1.2 milliamps. So I can just say right off the bat that I1 is 1.2 milliamps, right? Okay. Now I need to make an equation for the second loop and an equation for the third loop, and then I can go ahead and do some algebra to solve for I2 and I3, and then I can find my voltages. So that's my first equation. My second equation will be for this second loop here, and I'll start at the voltage source because that's just where I like to start. I go across this voltage source, I go up by 2 volts, right? So I write a plus 2 volts. And my mom's calling me. Hang on, Mom. I'm in the middle of making a lecture. I'll just call you back. Alright, love you, bye. Alright, bye. Alright, sorry guys. That was real brief. 2 volts, and now I go down across this 2K. I'm going to drop, right? But since the currents are flowing in the same direction through the 2K, they add. So I write I1 plus I2, and that's going to be times 2K. And then I go, man, it's just one thing after another. As soon as I start this video, my mom calls. I didn't want to start it over again, so that's why I answered it. Yesterday the computer decided to restart. Today it'll probably be something else. My computer might explode in the middle of the video. Alright, so I got my second loop equation, and now I need my third loop equation, but I like to simplify them first just because it's neater. So I'll instead write 1.2 milliamps, right? Because I already know I1, right? I1 is just 1.2 milliamps. I'm going to simplify this equation before I go and write my third equation. So it's going to be 2 volts. 1.2 times 2K gives me 2.4 volts. And then I have a minus I2 times 2K, a minus I2 times 1K. That gives me a minus I2 times 3K. Equals 0. 2 minus 2.4 gives me a negative 0.4 volts. And then I add this to the other side. I get I2 times 3K. And I divide both sides by 3K. And I get I2 equals, what is this going to be? I didn't grab my calculator. I am a wreck, guys. I am a wreck. So let's go to my calculator app and just do 0.4 divided by 3, 0.1333. So that's going to be negative 0.133 milliamps. Alright? That's my I2. Alright? And now what you may notice is I had 2 equations, 2 unknowns, because I knew I1 already, I could just plug it in, and then I don't even have to use systems of equations. It's kind of nice when you have a current source, and I gave you a current source on both of these problems, so my hope was that they would be easy because I gave you a current source, but maybe it was the superposition that tripped you up, but I'm going to go through the mesh anyways. So now I can make my third equation, which is for this loop, and I'll just start across this 3K. I'm going to drop by I3 times 3K, so I'll write a minus I3 times 3K. Then I get to this other resistor here, and my currents I1 and I3 are going in the same direction here, so I'm dropping, but I'm going to add them, right? I1 plus I3 times 5K, and then I go across this voltage source last, and that's a drop of 2 volts, minus 2 volts, right? And now again I can plug in my 1.2 milliamps for I1, so I go minus I3 times 3K, and then I've got a minus I1 times 5K, but that's actually a minus 1.2 milliamps. Sorry, let me just go ahead and carry out this step. Minus I3 times 3K. That 1.2 times 5K is going to give me a 6 volts. And then minus I3 times 5K. And then a minus 2 volts gives me 0. I can group these like terms, right? I3, 3K, and 5K gives me a minus I3 times 8K. And then that's minus 8 volts, but I'll add it over to the other side, so I get equals 8 volts. Divide both sides by negative 8K. And that gives me that I3 is equal to negative 1 milliamp. Alright, so I've got my 3 currents now, and now that I have my 3 currents, I can go ahead and solve for my 3 voltages. So you may notice, first and foremost, that I2 and I3 are both negative, which means that the way that I defined them is wrong. So there you go. This is proof that I don't know. Someone asked yesterday in class, like, how would you define your currents? This is how I would define my currents, but I was wrong about I2 and I was wrong about I3. They're both negative. And what I want everyone to I just want to clarify this just in case it's not clear yet. When I say I'm wrong about my currents, the direction I2 is clockwise or counterclockwise here, right? And that's negative 1.33 milliamps. It doesn't mean that this is wrong. What I meant is that the direction that I thought the current was flowing is wrong. So this I2 is negative 1.133 milliamps, which means that instead of, if I say negative 0.133 milliamps is flowing up through this resistor, that's the same thing as saying 0.133 milliamps is flowing down through that resistor, right? So that's just, that may or may not be clear to people, but I just want to make it clear. So I know that my drop is going plus to minus. I multiply that by 1K, and I get a 0.133 volt drop across this 1K, which makes this node voltage 0.133 volts. Right? Everybody see that? I hope so. And that checks out with what we got in Spice. So that's good that we got that. Now we also need to find VA2 and we need to find VA1. Well, VA1 is pretty easy to find because we know that I3 is negative 1 milliamp, and I defined it going this way, which means it's actually 1 milliamp going this way, right? So my drop of 1 milliamp times 3K gives me a drop of 3 volts across this resistor. And since I'm going from a lower voltage to a higher voltage, that means I need to add 3 volts, which makes VA1 3.133 volts, right? And again, that matches what I got in Spice, so that means that that's correct. And so now lastly, I need to find VA2, right? Well, VA2 can be found a couple of different ways. I could either find it, I know I1 and I2 both flow through this 2K, so I could find it by multiplying I1 plus I2 times 2K. So if I wanted to, I could say VA2 is equal to I1 plus I2 times 2K, right? And that would be, let's see, 1.2 milliamps plus, and then I2 is minus 0.133 milliamps times 2K. And so if I shove this in my calculator, I have to make that a negative. I add 1.2, and then I multiply it by 2. So my voltage is going to be 2.133 volts, right? Which is exactly what I would have expected because that's what Spice got. So this voltage right here, VA2, is 2.133 volts. And so now I'm done, but another way that you could notice that you could find that 2.133 is that I know this voltage right here was 0.133 volts. This is actually how I would hope that you would solve it. And then I just have a battery here, so I know this voltage has to be 2 volts higher than this one, so I just add 2 to this. So I could say VA2 is equal to 2 volts plus 0.133 volts, which would give me that voltage again. So that basically takes care of the mesh for 2A. And I'm going to go ahead and next solve for the, you know what, I'm just going to stop the video here. I'll make 4 separate videos. Yeah, so that I don't have to run the risk of the entire thing getting nuked again. Yeah, I'll just